Hello and welcome to this formula for Chemistry 30 in the Organic Chemistry unit. Today we are going to look at a type of compound called an aromatic. An aromatic compound contains something that we call the benzene ring. Okay, the generic formula for a benzene ring is C6H6, but those H's can be replaced with branches. So you could have C6H5, for example, and then a methyl branch on it. So that's what the formula would look like instead. Or you could have C6H4, for example, and let's say there's two methyl branches. Now it doesn't have to only be methyl branches, there could be other branches as well. Okay, but the key is that there's 6 things bonded around your 6 parent carbon ring. It's actually a ring, okay? And what it actually looks like, if I were to look at a line diagram of it, okay, there are 6 carbons in a ring, and there are alternating double bonds between every second carbon, okay? So if I were to draw this out, I have carbon 1, 2, 3, 4, 5, 6, okay? My double bond could be there, 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 or it can flip and be in the other spots, okay? That's why there's 2 variations. These are called resonance structures, 2 variations of the benzene ring. Now, how many hydrogens again does it have, or branches? Each corner can have one additional thing. Either it's a hydrogen or a branch. Okay, so that's where we get the C6H6. Now, because both of these structures exist interchangeably, we actually draw the average of this resonance, which looks like follows. You're going to have your benzene ring with a circle in the middle, just representing that these double bonds can move, and they do move, and they exist as the same structure. Okay, so you could see a benzene ring drawn as a line diagram with the alternating double bonds, or you could see it looks kind of like a nut or a bolt, a nut of a bolt, right? Where you have your 6 sides with a circle in the middle. Okay, now what are some properties of them? They are still nonpolar because they still only contain carbon and hydrogen. The ring structure is actually very stable because of the type of bonding that happens in double and single bonds with the pi bonds, what you get into more when you get to university. They're still considered unsaturated though, because I still have carbon to carbon double bonds. So if you ever have double or triple bonds, it's unsaturated. They are called aromatic because they actually give off strong aromas. Some examples of them are things like wintergreen, menthol, vanilla, cinnamon, mothballs, TNT, SPF and sunscreen, adrenaline, amphetamines, okay? So there's lots of different uses of them, but specifically ones that have certain smells are important to remember. Now, when it comes to naming these compounds, it depends on if the benzene ring is the parent or if it's a branch. If your benzene ring is coming off of the middle of a compound, it could come off the end as well, but if you're thinking to yourself when you're making your parent chain, if I were to make the benzene the parent chain, and then I were to say that this is a branch, let's say the branch, because I have to go through the ring and then make this a branch. Then I have a branch on a branch. You can't have a branch on a branch, okay? Same with over here. If I were to make this the parent and go through here, then, okay, this is a branch on a branch on a branch, right? That, again, can't happen. Plus, whenever you have a double or triple bond, that can't be a branch. A double or triple bond has to be your parent, okay? So you kind of get some practice with it for understanding. Usually, again, it's a branch when it's coming off the middle of a carbon chain, okay? You're going to name it a phenyl branch, okay? P-H-E-N-Y-L. It is called a phenyl branch. Okay, it does not take priority in numbering. It is just another branch in your compound. Your identification of numbering it Depends on the type of compound you have. Here I have an alkane, so I'm just giving all the branches I have the lowest number sequence. Now there's only one branch, so obviously we want it to have the lowest number, okay? But if there was multiple branches, the benzene does not have to have the lowest number, okay? It's just another branch. So numbering it left to right, my branch is on 4. 1, 2, 3, 4 if I number it the other way. So it is 4-phenyl is what we call the benzene ring as a branch, and the parent is just heptane. So 4-phenyl heptane. Okay, put the answer up. Good. The next one is a double bonded compound. When you have a double bonded compound, the double bond takes priority in numbering. It has to have the lowest number. Okay, then I name my branches alphabetically. So I have a methyl branch and 2 phenyl branches. LMNOP, methyl comes first. So it's 3-methyl and then 5,5-diphenyl. Again, for alphabetical order, the di doesn't change the order. I'm looking at a P versus an M. Again, I need numbers for every location of a branch. And the parent is oct-1-ene. Okay, let's make sure that's right. 3-methyl 5,5-diphenyl oct-1-ene. Okay, so that is when your benzene is a branch. When it's a parent, then you have multiple things coming off of it. Okay, then you're going to name it benzene. So this is my parent benzene ring, and that's a branch on it. That's a methyl branch, a 1 long carbon. I don't have to say where it is because no matter where it is, it would be called carbon 1. Right? If it's on that corner or that corner or that corner, it's all the same molecule just moving around. So I don't need to say 1-methyl. I'm just going to say methyl benzene. Now on a quiz, if you were to put a 1 here, I wouldn't mark it wrong. Okay? But you won't see on the answer key a number when there's only one branch on a cyclic structure unless it's a cycloalkene, because you have to say where it is relative to the double bond. Okay? So that's just methylbenzene. If you have more than one branch, you do have to number it lowest number sequence like before, okay? And name it alphabetically. So I have a branch here. I can make that 1, make that 2, make that 3. Remember, there's 6 carbons here in total. So this would be called 1-ethyl -3-methyl. And the parent is benzene. Okay, now I could actually, for this compound, number it this way: 1, 2, 3, 4, 5, 6, and then the name would be 3-ethyl-1-methyl benzene. Either way is acceptable. Okay. Then the next one, I can start 1 kind of anywhere because either way, I have a 1, 3, 5, 1, 3, 5, 1, 3, 5 for my branches, right? This is a propyl branch. These are methyl branches. So again, it really doesn't matter where you decide to start at 1. Your branches are on 1, 3, and 5. Okay, so if I do it like this, methyl comes before propyl, right? LMNOP. So it would be 3-5. 3,5 -dimethyl -1-propyl benzene. Okay, but again, those numbers could switch around and you would have the same answer. As long as you have the same number sequence, it would be acceptable to have that. Okay, so it could be 1, 3, 5. That's probably what the answer key would say because it puts it numerically in order. So some textbooks say that's the better way to number it. Or it could be 1, 5, 3. Okay? So a few different ways of numbering it. So the answer is, yes, the 1, 3, 5. Okay, but again, on a quiz, I would accept the other numbers as well because it's the same number sequence, as long as the number sequence is the same. Here's just a couple of examples of number sequences. If I have 1189 versus 1234, 1189 versus 1234. Sometimes students will say, well, there's an 8 and 9 there, so that's not the right one. But remember, you're comparing them one digit at a time, starting at the left. At first, you have two ones, so they're the same. But then you have a 1 versus a 2, so that omits this method. It has to be the first one. Even though there's an 8 and 9 later, it doesn't matter. I've also seen some students say a kind of a quick way to know which one it is if you were to put the numbers together, this would be 1,189. This would be 1,234. You always go with the lowest number, 1,189. Okay, it's another kind of shortcut. So I believe that's it for, exception. What is the name of this? Be very careful. There are no double bonds in the middle. There's no alternating double bonds or circle representing the alternating double bonds. So this is not benzene. This is 1-ethyl 3-methyl cyclohexane. Okay, so be very careful. You need either alternating double bonds in the diagram or a circle in the diagram for it to be benzene. Okay, otherwise it's cyclohexane. And that is it. So thank you very much for watching this video.